today, I'm going to try to keep this to 30 minutes today. I want to show how easy it is to kind of use our HD wallet in conjunction with the REST API gateway. It's just a really clever technique for getting the simplicity and the functionality out of the REST API gateway, but also doing signing, key custody on behalf of potentially tens or even hundreds of thousands of end users, making it very, very easy to perform that admin operation. We'll just touch on the core constructs of tokens as well, fungible, non-fungible, and the ability to swap those using a hash time lock contract. But more interestingly, something new that we haven't looked at before is actually a chain exerciser, a Kaleido Go repository that we have, which is really cool to basically just drive arbitrary workloads to your blockchain. So pretty nifty for simulating what would be, more or less a facsimile of your production environment. So you can use multiple workers, multiple loops, have synchronous, asynchronous threads, and pretty much just flood your chain with the expected amount of throughput. And this will help you figure out, can I run this infrastructure with small Kaleido nodes, or do I perhaps need medium or large nodes to support, a horizontally scaled application and multiple connections? So that's where we'll focus the bulk of the time on today, and just make everyone aware that exists, and everything that it can do, all the parameters that are available. Let me unmute the last person that joined, and then I'll just dive through this deck super quickly here. So if you guys, oh, cool, Frederick, good. Well, I'm happy that it worked for you. Frederick said that he tried the HD wallet approach and it worked, but that means I can't teach you anything new, but maybe everyone else can learn something new. If you guys have joined this before, I'm sure you've seen this deck, so I'll fly through it and we'll get to the actual blockchain layer in the tech. So here we go. Okay, so 3 high-level characteristics really define Kaleido. Built for modern business networks, use case, industry agnostic. We have production clients spanning supply chain, spanning capital markets, entertainment, real estate, etc. Radically simple in a lot of different manners, both at the blockchain layer, at the services layer, and at the transaction layer. We'll see that both with this sample exerciser we have and with the REST API gateway. And then lastly, we'll start looking at a lot of these new sort of enterprise features in upcoming demos, specifically Cloud HSM signing, but enterprise in the DNA of the platform. So HA, DR, auto scaling, really extendable signing techniques, encryption, on and on and on. So what we've done with Kaleido is we've taken a lot of measures to really flatten the adoption curve, starting with just getting comfortable with blockchain, with Ethereum, with peer-to-peer protocols, smart contracts, and then giving you a really easy paradigm, really easy framework to get to a pilot stage, decentralize your network, add governance, and then roll that directly into production with dynamically scaling environments, and the reliability and the robustness that you need for high throughput, really scaled environments. Again, I think most people have probably already seen these decks, but just flying through them. One thing we definitely realized working with all of our partners, all of our clients, blockchain, really important. Those are the nodes, those are the smart contracts. That's where blocks are mined and the algorithm takes place. But inside of a solution, there are a lot of other things. You need answers for storage, you need answers for digital assets, for privacy, for identity. And the full stack solution really kind of asks for all those layers to be addressed, starting with the data layer, integrating your private data off chain into the blockchain, transacting using Quorum or Hyperledger Besu for private transactions, consuming events reliably coming from other participants in your network, integrating with your identity access management providers, your OpenID systems, integrating with oracles, allowing your apps to communicate to each other, integrating with all of your other back office systems. And then at the actual application layer, right? Figuring out the throughput that your infrastructure needs to accommodate. How are we going to model assets, fungible, non-fungible, if we're using tokens? Do we need to use zero knowledge proofs to have complete anonymity and privacy and confidentiality? And then our REST API gateway, making it very, very easy to submit transactions, but also integrate with wallets like our HD wallet to sign those objects. So just the platform itself littered with APIs in a good way, really, really powerful services that address all of those tiers inside of the stack, and really just an infrastructure where you can focus on your application, on your business logic, on your smart contract, and not have to worry about the runtime layer, about the plumbing, about mining blocks, consensus, etc. Super high level, what Kaleido is good at, makes it very easy to do. Create as many instant networks as you want, tokenize assets, cross clouds from AWS to Azure to even on-premise, share the ownership of your network with permissioning, onboarding external participants, building out your full stack solution with our full stack marketplace, and then getting sort of onto the bleeding edge of some really fun stuff with ZKPs and smart contract management and tethering to the Ethereum mainnet. So enterprise definitely in the DNA. You can see here about 12 bullet points of what you get pretty much out of the box with Kaleido. ISO 27000 certification, a lot of stuff around key management, one of which we'll look at today, another which we'll look at next week. But then just SLAs, 24/7 support, HADR, the ability to weave your private cloud services into the runtimes, backups and log streaming, for example, and then the ability to just cross clouds, right? AWS, Azure, on-premise. Quick snapshot of some of the customers and clients running in production on Kaleido. So it gives you an idea of, truly industry and use case agnostic, spanning, capital markets and banks to energy majors, retailers, brands, etc. Just a few of the use cases that these folks are tackling. Green Fence is a particularly interesting one. They're working with these brands and retailers and movie studios using non-fungible tokens. Covantis and Comgo, solving kind of antiquated problems with letters of credit and commodities trade finance. Atato doing supply chain and provenance. Union Bank in the Philippines tokenizing their fiat currency and onboarding rural banks that don't have sophisticated infrastructure and connection to the modern banking pipes and rails. And then lastly, for folks of, that are in startups, that are in enterprises, that are in, if you're an SI, et cetera, there's a really flexible package somewhere in Kaleido that addresses, every company of all sizes and every stage of the project, whether it's our free starter tier, whether it's sort of an innovation lab package, or whether it's a custom contract that, we bespokely create, based off of, the needs of a particular business network or a particular shop. Lastly, the final bullets, objectively rated #1 BaaS on the market, really, really awesome industry first innovations, zero knowledge proofs and mainnet tether, and then just enterprise in the DNA and cross cloud. Okay. So here we are now in Kaleido, and what I did was I created an example consortium and a single environment, 2 memberships, ABC, XYZ, and then just a Geth POA environment with an HD wallet service in it. So the first thing that, I guess I'll go backwards, we'll do the chain exercise or last. First thing we'll do is we'll just look at our REST API gateway and signing with the HD wallet. So just to give everyone a refresher, here's the REST API gateway. This is where Kaleido is removing the need to use an SDK or a Web3 client library. And this shim, ETH Connect, the REST API gateway, is going to do all of the heavy Ethereum lifting, specifically the sequencing and the mapping of those transaction objects. But it's also going to do the signing. So we can tell Kaleido how we want to sign the object. Do we want to sign it off platform with the Cloud HSM? Yeah, we very might want to do that, and we'll look at that next week. Do we want to sign it using just a utility wallet, ETH wallet that we provide? Perhaps. Do we want to sign it, using an account on the node? Perhaps. Or what we're going to look at today is if you have hundreds and thousands of end users, it's not feasible to spend the money to put all those private keys into an HSM service. The nodes and the ETH wallets, they can't sustain that memory, that number of accounts. So that's where an HD wallet makes sense. And you simply map your end users that are in your IAM system, in your OpenID system, LDAP, et cetera, to an index inside of your HD wallet. And then you just tell the REST API gateway which HD wallet you want to use and which index, and then that object gets signed. It's really cool. So coming back to Kaleido, I'm going to go to the new console, and we'll just create simple storage as a contract project. We'll compile it, and then we'll instantiate it, and we'll go into the gateway, and we'll use this HD wallet to sign an object. So for those that haven't seen Kaleido version 2, here it is. And again, this is not a preview or something secretive that only I can look at. This is available for, excuse me, for everyone to explore. And it's really, really fantastic with just being able to visualize, data in a really modern way, whether it's, addresses and, Ethereum accounts, all the way down to smart contracts and really low-level granular data on the chain. So what we're going to do is we are going to go to our network view right here, and we're going to create a shared asset. We're going to create a contract project. So a lot of the flow is the exact same as on V1. This is just more of a cohesive, intuitive representation of all of the functionality and all the assets that you have inside of the platform. So we'll create our contract project, which we've done many times before. It'll be simple storage again. Sorry for the exact same Solidity code. And then we'll import from GitHub. Click finish. So here's the high level details of the project. And now we want a compilation. One cool new thing that we've added here in version 2 is for failed compilations, stuff that can't get deployed onto your chain, can't generate a gateway out of it. You can actually delete those compilations. So you're not going to end up with a congested, kind of a saturated contract project with a lot of useless compilations. So if you do want to do that maintenance, that cleanup, that is now available. I particularly think that's a very useful feature. So we'll create our new compilation, and we'll tell Kaleido to go grab the simple storage source code, which is in a different repository. So this is our Kaleido Go repository, which we'll use here at the end, but we want our Kaleido JavaScript repository. So inside of our contracts folder, we have simple storage version 5. And again, for new folks, these are all public repositories. So you can go to GitHub Kaleido-io, and you'll see about 8 or 10 or maybe even upwards of a dozen now public repositories with examples, with drivers, etc. So this guy just has a single global variable. It takes an argument to the constructor when we deploy it, and then it has a setter that needs to be under 100, and it has a getter and then a redundant getter. So we'll tell Kaleido about this URL right here, and then we're good with all the other stuff. Single contract, public repository, and we can just let Kaleido auto detect that. So this uses a little Lambda serverless function to go ahead and grab that and perform that operation. And this will compile in about 5 seconds. So you're good to go. And we see a nice notification that it hasn't been promoted to any of our environments. We see our ABI, we see our bytecode, we see no dev docs because they aren't commented out. And then we see where it came from in the commit hash, Solc version, etc. So we'll promote this guy to our single environment. We'll give a name to the APIs of the compilation, our gateway API, and we'll go to development. Just to touch on this and reiterate, the idea here with this is just normal DevOps promotion. Create a project, create some compilations inside of it, test, go to development, go to staging. When you have your behavior, you have your logic, you can take the exact same gateway and you can go into your production environment. So click finish. And again, here we have a view of our gateway API inside of our environment, inside of our gateway API's view, and inside of our specific gateway API simple storage. So we can view this guy through the lens of node number one, and this is going to be the exact same Swagger interface that everyone's comfortable with. All right, so here's our gateway endpoint. Here we have all of the methods, but we want to use the root post here to go ahead and instantiate it. So to start off, I'll just use the default account on node number one, and then when we want to go invoke it and update the state, that's where we'll use our HD wallet. So I'm going to call this simple storage 123. We don't have to use hexadecimal anymore, and I'm going to submit it synchronously, meaning we're going to wait for that response to come back. And we'll give him 123. So again, this turns our definition, those APIs of the compilation, into an actual instance, an on-chain deployment of that smart contract. So we can close this, give this a quick refresh, and we see our instance. Didn't even need the refresh. So we see the address, we see who it's deployed by, much cleaner views to kind of interact with, your on-chain logic and extra visualization. So what we'll do now is we will actually use our HD wallet instance to sign an invocation of that set method, and I'm going to do this from the classic Kaleido console here. So first of all, what we want to do is we want to open up this Gateway API tab and get into our instance again. So I will do that, view the instance. I didn't save my credentials, so I'll generate some new ones. And now we have that same Swagger interface here. So if we call get, we'll get back 123. Okay, but we're not interested in that. What we want to do is we actually want to update the state using the set. So again, excuse me, the KLD from parameter is just you telling Kaleido what account do you want to sign this with. That account can be on the node. It can be an account you created through our API or through the JavaScript interface. It can be an account in a Cloud HSM service. It can be an account in the ETH wallet service, or it can be an account inside of an HD wallet service, which is convenient for not only sign and throw away for anonymity, right? One-time usage, but very useful for account management. So this is what we want to update. And the syntax is HD-service ID, right, for your HD wallet service on Kaleido, -wallet ID, because you could have multiple wallets inside of your service instance, and then the index inside of that wallet. So spanning from 0 to, I believe it's 2.8 billion with a B. So you have lots of accounts available inside of HD wallets. So inside of our environment, we just need to go grab those pertinent details. So here's our service, our HD wallet, have some cached credentials. And then this is what we care about right here. Oh, I need to actually create a wallet. So first we'll do that. There's our entropy, our mnemonic, excuse me, and there's the wallet ID. So now we can actually go interact with this wallet. So this is what we care about. This is our environment ID right here. This is our service ID for this HD wallet service. This is our wallet ID. And then inside of this wallet, we have many, many, many accounts, right? So we can browse the wallet. We can look at account 0, or we could look at, account 10 million. And again, these in this scenario, these would all map back to some end user in your identities in your IAM service. So we'll use account number 1 inside of it, and this is the private key that'll sign the object, and here's the address when we go ahead and explore it. So 5F7. All right. So close out of this, and let's go grab our service details. So first we want this, the service ID. And then we want that wallet ID, which is this guy right here. And we will use account number 1 with a single dash. Okay, let's see if that looks good. HD, service ID, wallet ID, account. We'll submit it synchronously again, and then we'll just update this. This needs to be under 100 if we recall. Go ahead and click try. And again, this is me in the Swagger interface. This should all be done. Typically, this would be done programmatically with, your favorite, programming language, Node, and a Swagger client embedded inside of it. So cool. So we see that that worked, that that transaction was signed off, that it was from 5F7, and that we've used, this utility sort of as a proxy signing service. Again, this is useful for two things. For one-time use of signing transactions, if you just want anonymity and don't want to be tracked back to an address, but perhaps more interestingly, it's great for end user account management. So we can go back here, go into our new console view again. Told you we'd be doing some hopscotching, and we can look at our data explorer. So now inside of our block explorer, we see that we had the instantiation of that smart contract, and then we had the invocation of that smart contract, right? So here was us bringing the smart contract to life, and now here was us actually calling simple storage, right? So we have this, we have these rather, low-level granular views of what's going on the blockchain. We can even see the method that was called and the arguments that were passed to the method. We don't have to deal with, pretty much indecipherable hexadecimal anymore. So that's at a super high level, just HD wallet in conjunction with the REST API gateway. Glad to hear that someone's already gotten it working. That's really encouraging. So we'll go back. I'm going to fly through the tokens today, but I just want everyone to know that these utilities are there. So I'll create a factory service for each of my memberships here. ABC, and then for XYZ. Oops, should have clicked add another service. Now we'll create one for XYZ. And we can use these utilities to basically create ERC20 or ERC721 smart contracts. We can mint tokens, we can burn tokens, we can pause, we can transfer, etc. One cool thing to use, the token utilities in conjunction with is the swap service as well. We've shown this before, so I think I'm going to skip it today, but rather than using a third party to act as your intermediary in a transaction, where oftentimes, you have, valuable assets on the line, instead you can use a piece of software. You can use what we call a HTLC, a hash time lock contract, that is going to be the custodian of those assets, and it'll allow for an atomic swap to happen. Pretty much a binary operation where, either both parties are getting the counterparty's asset or they're both going to be returned to them. And it has some protections built in around double spends and, how it could technically be exploited. There's still some responsibility that's on each of the end users to act in a timely fashion, but there isn't a pure vulnerability in the sense that a single party could wait until the lock was about to expire and then double spend or withdraw both assets. What I'll just show is how easy it is to just create, one of each token smart contract types here. So let me just hop back in here. Again, I only have a single account with this membership right here. Actually, I have two nodes, so I have two accounts for ABC. And what we'll do is we'll just create an ERC20 token. We'll sign it with this account right here, and this will be the owner. So this could be like loyalty points. This could be, US dollars, euros, anything that's fungible where everything has the same value. So I'll just call it loyalty points, loyal. Choose the attributes, burnable, mintable, pausable, etc., and then give it a supply. So say 1,000. And create the contract. And this will, instantiate this token smart contract with 1,000 tokens, which will all belong to this account right here, 189. So click deploy, and then whichever node owns this account, it's either node 1 or node 3, inside of their wallet, we'll see a balance of 1,000 loyal inside of our Geth POA environment that we have here. Okay. So node number 1, this is his 189. Click his wallet, click that address. So we see that there's 1,000 loyalty points bound to that address. So super, super easy to use, and then clean REST APIs behind the scenes to call transfer, to call mint, to call burn, etc. We'll skip the non-fungible one. It's the exact same semantics, either using the console, using the interface to create it, or using the service APIs. The one thing just to bear in mind with a 721 is the contract itself is not very interesting until you start minting tokens inside of it. So you can create a 721 contract and it's basically just an empty namespace. You need to start minting NFTs inside of it and giving those NFTs to certain accounts, certain end users. From that point, then you can swap them, you can exchange them, etc. Okay, so the final piece, I'm not gonna quite make my half-hour promise, but we'll get out of here in the next 5 minutes. The last piece we wanna look at is our Kaleido Go repository. So this is just a chain exerciser. It's gonna use a simple storage again, but this lets you, as I said at the beginning, this lets you really mimic how a proper, potentially decentralized or horizontally scaled architecture would be. You have a bunch of different interesting parameters that you can use. So you can create multiple accounts inside of your node or on an ETH wallet. You can specify your arguments to your smart contract. Obviously, you don't have to use simple storage. You can, upload your own contract inside of this repository. We'll compile it for you. You have the ability to externally sign transactions, create your own, Web3 key stores and JSON files, sign those with your own private keys, or you can use those accounts on the node to do it. And you can create multiple loops and multiple workers to try to mimic, those individual clients here. So what we'll do is we'll just send in a big workload of maybe like 5 workers and a couple of loops and 5 or 10 transactions a piece. So the first thing that we need to do is we need to make sure we have enough accounts on our node. So I'm going to use node number 1 to process these guys. So we'll go to node number 1. We'll go into his wallet. He's the lucky owner of those 1,000 those 1,000 loyalty points, and we'll create a handful of new accounts for him. So again, this can be done via the Kaleido API, can be done in the console, can be done in the JavaScript console via the Ethereum interface. So I think 5 will do for these purposes. And then when we run the program, we're just going to enumerate these accounts. So each worker, basically each client, is going to use a different account to sign. Okay. So here's a few that I already ran through earlier. For folks that are interested, this is a Go program, so it needs to, the executable needs to live inside of your Go path. So we can say, PWD for me, and then echo Go path. And we'll see that my Go path is NetGasky work right there, source GitHub, and then here's our executable. I had to upgrade to Go 1.14 to get this to get the build, the Go build to actually work. And I'm using this version of the compiler 5.17. Just for folks that want to recreate this, if you end up with a failed build or the ability to the inability to compile the simple storage. Okay, so the first thing we need to do is we need to call Kaleido Go, and we need to tell it where the file is that we're going to use. It's inside of our inside of here, we have an examples folder, and that's where simple storage is. Okay. And we actually have some sample syntax down here, some sample commands to kind of get us going here. Okay, so first we're going to deploy that, so it'll compile it, it'll instantiate it, and then we're going to call the set method inside of it and pass it, some arbitrary integer here. 1, 2, 3, 4, 5 is the example. So we'll call the method of set. We'll give it our argument. I'll say just 1, 2, 3, 4. We want to use 5 workers. So -w is the parameter for workers, And again, the workers are the clients here in this scenario. We want to do 5 transactions a piece for all of these. We want to do 2 loops or 3 loops or 4 loops. I'll just do 2 for the time being. We need to tell Kaleido about the endpoint, the actually fully qualified node endpoint that we're going to use here. So that's the -u parameter. So we'll go back into our Kaleido environment. We're on node number 1. So I'll go into connect the node, and I'll just grab that fully qualified string, right? This is what we would use with, you know, a Web3 client library. It's what we would use with Truffle, Web3.js, Nethereum, etc. We need those app credentials to be inline. So -u, and then we need to use all of those accounts. And I think that's all the parameters that we need. If this fails, we'll go back and we'll find the parameter that we missed here. So the last thing is we want to go into the wallet and we want to grab those accounts. So just one by one. So copy, -a, paste, -a, and we know this works because I just did it earlier. So if something goes wrong, that means I've typed something in incorrectly into the keyboard as I'm trying to multitask. And we also know that it's an honest live demo if something goes wrong. If everything's perfect all the time, then what's the point of using software and using these emerging technologies? Okay, so there's my node right there, fully qualified. There's the 5 accounts, 1 account for each of the workers. We want 5 transactions apiece. We want 2 loops. I think that all looks good, so let's give it a go. Okay, so it's sent. Now we want to see if this can get mined. Okay, so here's our contract address. So we're seeing the submission of those transactions, and then we want to see the actual execution of those transactions as well, right? So we're getting that it was mined as well right there. And when this is all complete, we'll get more or less a unit test letting us know how many were, excuse me, actually successfully submitted end to end. So there we see that we got 50 all the way through. And like I said, right, you can use this basically to whatever threshold you think your application is going to require. So, you know, again, we can modify some of these parameters here if we need to. Actually, you know, we could do 10 transactions a piece, for example, or we could do 5 loops rather than just 2 loops. Pretty much anything that, you know, makes sense for your specific use case here. Bear with me as I slowly and painfully scroll through here, but what we'll do is we'll just run a handful of additional transactions, and we'll call that specific smart contract address this time. So we can run 3 loops this time. We can do, you know, 10 transactions per worker, and we'll keep it at 5 workers. So the only other thing we can do is we can pass the C parameter right here, and we can go and find our smart contract address wherever it was returned to us. So rather than creating a new smart contract instance, we can now interact with that guy that we just deployed. I think I need 1 more space there. Okay, so looking good. This should be good to go again. And again, this is just, you know, perfect to kind of like introduce problems. So you can, you know, specify, you know, nonces and do yourself a nonce mismatch and create pending transactions. You can scale it all the way to, you know, maybe 50 workers and see if, you know, you really need large nodes or you need medium nodes in your infrastructure and your deployment. And then this will help you give you an idea of, oh, okay, I do need to be on the enterprise plan. I need an SLA. I need large nodes, etc. But one super cool thing as soon as this is done is that we took a quick look at it, but the metrics in version 2 of the console are really, really slick. So there we see that this is running perfectly. For me, I do have medium nodes deployed, not small nodes at the moment. So if we click the version 2 of the console, we can start to see, you know, some more interesting metrics inside of our node right here. right? He's actually using some of these resources because we're submitting, a decent amount of load of throughput through it. But inside of our dashboard, now we can go to our data explorer, go to our block explorer, and we're going to see, some more interesting things here, right? 201 transactions, some more interesting metrics and monitoring. And then we can look at the runtime of all of our resources here, and we'll see these guys actually doing a bit of work inside of the network. So this is super nice for just systems administrators, for network operators, and folks that need this high level and really low level monitoring. So yeah, I really encourage everyone to log into Kaleido, experiment with whatever services, whatever features you want. Probably know by now I'm a big fan of the REST API gateway. Yeah, use this program. You can drive some load, give a stress test, a performance test, and then just experiment with version 2 of Kaleido. There's some really fantastic improvements that have been made inside of the console. And again, remember, there's an API behind everything. So as beautiful as it looks, you can also access all the information with an API. So I'm going to call it quits there today. That was, I think, my most efficient demo to date. But I think we covered a decent amount of really useful information as well. So everyone's unmuted if you have any questions. If you'd prefer to communicate offline, I'm going to share my email inside of the chat, if I can find the chat. And feel free to contact me with any technical or commercial queries. Like I said, at the beginning when we were going through the deck, we have a bunch of different flexible packages, for startups, for enterprises, medium-tiered companies that'll, really help you get to the finish line and get your project out of this, bubble inside of your head into an actual pilot and hopefully into production. So happy to discuss any of those in more detail. Also happy to address any technical questions that folks have. One final thing in terms of technical questions, inside of the console, we do have the Contact Us feature. So if you have a sales inquiry or you have a technical question or want to report a bug, you can just submit a ticket and this will map to our broader engineering team and you'll get a full line of sight on this, across the entire Kaleido team. So great way to get in touch with us as well. All right. So going once, twice, 3 times for questions. Nothing today. All right. Well, thanks again, everyone, for showing up and attending. Again, we're going to add some new material going forward, and version 2 will, reach its maturity here very shortly. So we'll see all the services and all the stuff you can do in Kaleido Classic and Kaleido V2. But we will touch on some more OpenID integrations, cloud HSM signing, pretty fun features. So thanks again, everyone, for attending. Hope you stay safe, stay healthy, and please reach out if you have any questions via the ticketing system or directly to me. Have yourselves a great Tuesday.